All right, so we've already talked about how to solve a system of equations. We reminded ourselves of what a system was, that a system is two or more equations, and that their solution is where those two or more equations could cross, and that's the point where they intersect. It's the points that make both equations true. So we did it graphically before, meaning that we took each equation, we graphed it, and then we looked at the graph to see where they crossed. Now we're going to do it algebraically. And there are two different methods when you solve a system of equations algebraically. One is using elimination, the other is using substitution. So these notes are going over each of the different ways. So first, with elimination, your goal is to get the x's to cancel out or get the y's to cancel out. And we typically line them up exactly like this because what we're going to do is we're going to add the two rows together and get something to cancel. Now, this first problem is interesting because you actually have two different ways you could make this work. We could multiply the entire bottom row by 5, so that we would have a positive 5x and a negative 5x that would cancel each other out. Or we could multiply the entire top row by -2, because then we would get a -6y and a positive 6y that would cancel out. It does not matter which letter you cancel first. Eventually, you're going to take care of everything. So what I'm going to go ahead and do is take the entire bottom row and multiply it by 5. So I'm going to take the top row, I'm just going to copy that down, -5x plus 3y equals -25. And then I'm going to go ahead and take the bottom row and multiply the 5 all the way through. So we've got 5x plus 30y equals -140. I should use my calculator to make sure that I'm good. 28 times 5, ooh, -140. All right, so now if I add these rows up, those add up to 0, which is what I wanted. 3y plus 30y is 33y. And then 140 and 25 gives me 165, and that's -165. So now I've got 33y equals -165. I'm going to go ahead and divide by 33. And I get y equals -5. So if you guys remember, we always want our solution to be written as an x-coordinate and a y-coordinate. So what I've done so far is I've found the y-coordinate where the two lines intersect, but I need to find the x-coordinate. So you've got two options. You can take the -5 and you can plug it back into the first equation and solve for x, or you can plug it back into the second equation and solve for x. So I'll go ahead and plug it back into the second equation just because that one looks a little bit easier. So x plus 6 times y equals -28. X, that's -30, equals -28. And then I'll go ahead and I'll add 30 to the other side. X equals 2. So when I'm done, I'm going to go ahead and write the point as 2, -5. And then I'm set. So if we had graphed the equation, I went ahead and graphed it in Desmos and I printed it out. If I graphed these two equations, the blue line is the first one, so there's the blue line, the second one. And if we looked at where they cross, it would be the point 2, -5. So this is what we would have gotten if we did it yesterday. Now, doing it today, we're going to go ahead and do it by hand, which means we're doing it algebraically. All right, let's go ahead and try the example that's right underneath that. So for this one, I'm going to say, okay, this is -6 and that's +3. So if I take the entire second row and I multiply it by 2, then I'm going to go ahead and carry the first row down. And then I'll distribute the 2 to the second row. So 2 times 3x is 6x, 2 times 4y is +8y, 2 times 7 is +14, and now we're going to add these up. So negative 6x and positive 6x, negative 8y and positive 8y, negative 14 and positive 14. And what we end up with is 0 equals 0, which is a true statement. What that means is that both of these lines are exactly the same. If I was to graph them, I'd be graphing one line on top of another. They'd be exactly identical. And so what we say for this is we say infinitely many solutions. Infinitely many solutions. All right, now I did the same thing for this one. You can see that I have my two equations. I've got a purple equation and a black equation. And when you look over here, you can only see the purple line because I graphed the black one first and the purple one went right on top of it. And so this is infinitely many solutions because the two lines are intersecting for the entire time they are being graphed. So you've got this point right here, that's a solution. You've got that point, that's a solution. This one is a solution here. We've got another solution down here. So you've got solutions throughout the entire line. All right, let's go ahead and jump up here and look at this one next. So I've got a negative 10 and a negative 2, a negative 5 and a negative 1. I'm going to go ahead and take this and multiply the bottom equation by a negative 5. And the reason I'm going to do that is because when I do negative 5 times negative 2, I get positive 10, and that's going to cancel out that negative 10. So I'm going to go ahead and drop down that first equation. And then I'm going to go ahead and distribute through that negative 5. So negative 5 times negative 2 is positive 10. Negative 5 times negative y is positive 5y. Negative 5 times 0 is 0. And now if I add these straight down, I get 0, I get 0, and I get 1. And that is not true. And so this is where we say no solution. So this is one of those problems where if we graphed it, we would see two parallel lines. They would never cross. All right, so I graphed these two. I got a red and a blue line this time. And if you guys can see, this is 0.5, 0.5, 0.5. These two lines are very close together. I had to really zoom in so that we could see that these two lines are parallel. They do not cross ever. They are not on top of each other. There's no solution. There's no point where those two lines will intersect. All right, what I want you to do right now is pause the video. See what you can do with this problem. So if I look at it, 2 and 7, those are not going to cancel out very easily. However, I have a 2x and I could multiply the bottom row by something to make it cancel with the 2x. I want them to be opposite signs. So I want something that's going to cancel with a positive 2. I need to multiply that whole row by the number. So go ahead and try this problem, pause the video, try the problem, write your answer down. When you're done with the entire video, you're going to text me or send me an email and tell me what answer you think it should be. All right, let's go ahead and try the next set of problems. So for these ones, we're going to solve the system using substitution. So if you can see, both of these equal y. And since that is the same letter, that means these two things have to equal each other as well. So what we're going to do is we're going to set them equal. Negative 4x minus 13 equals negative 3x minus 9. And then I'm going to go back because now we've just got a regular equation. And I'm going to remember what we learned on the first day about with the x's, we want to pick on the little guy to get all of the x's to one side. Negative 4 is smaller actually than negative 3 because it's more negative. So that's the little guy I'm going to pick on. So I've got negative 13 equals 4x minus 9, not 4x, 1x, sorry. And then I can go ahead and add the 9 to the other side. So x equals negative 4. And then if I want to solve for the y coordinate, I can plug in that x value to either equation. It does not matter which one I choose. I'm going to go ahead and do the first one. So I get y equals -4 times the x value that I got, minus 13. So y equals 16 minus 13, which means that y equals 3. And then I always make sure that I write my solution as a point. So -4 for the x, 3 for the y, and I'm done. Now this problem is a little bit different. You have one equation where the y is all by itself, and the other equation the y is not all by itself. So what we're going to do is we're going to take this y and we're going to stick it in right here. So we're going to have -x minus, we're going to plug y in, equals -4. So -x minus y equals -4. We know that this is where the y goes. And this tells us that y is equivalent to 5x minus 20. So we took what we knew that y equals and we substituted it in for y. All right, now I just need to go through and get rid of parentheses. So the -x is going to drop down, but this negative should be distributing to the parentheses. And now that I've done my distribution, I need to check and see if there's any like terms that I can combine, and there is. We've got -6x. And then I can move the numbers away from the variable, so I can subtract the 20 over. It helps if you remember the x in there. And then to get the x completely alone, I'm going to go ahead and divide by -6. So the x coordinate of my point is 4. And to find the y coordinate, I just need to plug the x in. And I can plug it in right here and solve for this y. Or I can plug it in right here and solve for that y. And since this y is alone, I think that would be a little bit easier to do. So that's what I'm going to do here. Y equals 5 times x minus 20. So y equals 20 minus 20, which means that the y coordinate is 0. So our solution is 4 for the x coordinate, 0 for the y coordinate. All right, go ahead and flip the page over. All right, with this one, if you look here, we don't have the y's by themselves in both equations. We don't even have the y by itself in one equation. But if I look here, I think that this y right here would be pretty easy to get alone. So that's what I'm going to do. I'm going to minus the 6x over. So I have y equals -6x. And now I can go ahead and use substitution to plug it into the other equation. So I have 2x plus 2 times y equals 10. And then instead of y, I'm going to plug in a -6x because I know that that's what y equals. So I've got 2x minus 12x equals 10. I can combine like terms right here. 2 minus 12 is -10. Then I can go ahead and divide by -10. And I get x equals -1. All right, so now I want to solve for y. And I do that by plugging x into one of the equations. So I can plug -1 in up here and solve for this y. Or I can plug -1 in here, solve for that y. Or I can plug -1 in right there and solve for that y. It does not matter what I do. So I'm going to go ahead and use the first equation. I've got 2 times x plus 2 times y equals 10. And then that's -2, so I'm going to go ahead and add 2 to get the y's alone on the left side. and that gives me 2y equals 12. And then I can go ahead and divide by 2, and I get y equals 6. All right, so and actually I should not box that because that's not my final answer. So I have an x coordinate of -1, a y coordinate of 6, and so my final answer is -1, 6. All right, for this one, I've got x's and y's, and if you look, this is the only variable that looks like it could be easily by itself. So what I'm going to do is I'm going to take that equation, and I'm going to get the x by itself by adding the 3y over to the other side. So x equals 3y plus 5. Now what I can do is look at the second equation, and where I see an x in the equation, that's where I'm going to plug this stuff in for x. So I have 6 times x plus 8y equals 4. And I'm going to go ahead and let you guys solve the problem from there. So at this point, you've got this example, and you've got this example, and I want you to do both of them on your own sheet of paper, and you're going to text me the answers. Or not your own sheet of paper, you can do it on here. I want you to text me the answers or send them to me through email so that I know what the answers are for those. All right, last little bit of notes. Remember, the solution of a system of equations is a point, and it should be written in the form x, comma, y, always. I always, always, always need to see your answers written like this.